Hello everyone. Today we will study about angle of friction and angle of repose. Now you are familiar with the concept of friction. So these are important angles which are related to the concept of friction. So for that we need to define the angle of friction and angle of repose, right? So what is angle of friction? The angle which the resultant of normal reaction and limiting friction makes with the normal reaction is called angle of friction, and this will be clear with the diagram. Okay, so first of all let me write the definitions of both. So what is angle of repose? The minimum angle of the inclined with horizontal at which an object placed on it just begins to slide. This is called as angle of repose. So we are discussing these two concepts in a comparative way so that there is no confusion at all. So for that we need to draw the diagram. Suppose a block is kept on a surface. This is the surface. If the applied force is in this direction, the friction force will be in opposite direction. Obviously the normal reaction will be normally outward to the surface. So what is angle of friction? Angle of friction is the angle which the resultant of limiting friction and normal reaction makes with the normal reaction. So this is the resultant of limiting friction and normal reaction by parallelogram law, because if we have two vectors like this, co-initial vectors, then the resultant of these is given by the diagonal of the parallelogram. So if we look at these vectors, these are two vectors, co-initial vectors. So the diagonal of the parallelogram formed by these vectors will be the resultant of these two. Right? So here, as I told you, the angle of friction is the angle which the resultant of normal reaction and limiting friction makes with the normal reaction. So that means this is the angle of friction. Suppose I am denoting this angle of friction by theta. So Fs maximum is called as limiting friction. Now let's look at the diagram again. This vector is Fs maximum, so this vector will also be Fs maximum. So using trigonometry, you can write this angle in terms of this vector and normal reaction vector. So how can we write that? Tan theta is equal to perpendicular upon base. So what is the perpendicular? And base is normal reaction. So tan theta is Fs upon normal reaction, and we know that F is equal to mu into normal reaction by laws of friction, right? So we can replace this by coefficient of friction. So therefore tan theta is equal to Fs upon R is equal to mu. So if this is limiting friction, so this will also be mu as max. So that means tan of the angle of friction is equal to coefficient of limiting friction. Now we talk about angle of repose. So again, for that we'll first draw the diagram. So this angle of repose is for an inclined plane. So if an object is kept on an inclined plane, the weight acts downwards. This angle is a particular angle which I'll explain now. If you have this horizontal surface and you keep some object on it, it is kept like this. Now if we start giving inclination to this object with respect to the horizontal, at some angle with the horizontal it starts sliding down. So that angle of the inclined plane with the horizontal at which the object just starts sliding down, this angle is called as angle of repose. So this angle of repose I am denoting here by phi, and this is the angle at which it just starts sliding down. We know that the normal reaction always acts normally outward to the surface. Now friction force is the object is moving this way, so the friction force will be this way, and we are calling it again limiting friction, the maximum static friction at which the body just starts moving. And now this inclined surface, we are taking our horizontal surface because we are observing the motion of the body on this surface, and this we are taking as vertical. So we need to have all the vectors in these two directions. Normal reaction is already in this direction, limiting friction is already in this direction, but weight is in oblique direction with respect to this and this. So I need to find its components along the vertical direction and the horizontal direction. Now for this, I will have to find its components. For this I need to have this angle. If you remember, we had discussed that this angle will also be phi. Why? Let's do this exercise here. So if this is phi, this is 90. This is suppose x, right? And we have to find this angle. So x plus phi plus 90 is 180, right? So that means x is equal to 90 minus 5, because 180 minus 90 is 90 and 90 minus 5. So that means this angle, this complete angle is 90 and this angle is x. So obviously this angle will be 5, because we know that 5 plus x here is 90. So x is 90 minus 5. Therefore, this angle will be 5. So again, we don't need to calculate this again and again. Just remember, angle between two lines is equal to angle between their perpendiculars. So this will be angle 5. Now look at this. This will be mg cos phi. If you remember to find the components, how to find the components? If you have this vector A, this angle theta, then this component along the angle is A cos theta. And the perpendicular component is A sin theta. So similarly, this one is mg cos phi and this one will be mg sin phi. Now look at this. This body is sliding down without acceleration. So I can say that net force mg sin phi is equal to Fs max. So no acceleration. That means mg sin phi is equal to Fs maximum. Also one more equation we can write from here. There is no vertical motion in this direction. The body is settled on the inclined plane. It is not moving in the air. So R is equal to mg cos phi, right? So again, I can divide these equations. If I take this as one equation, this as two equation. So I am dividing one equation by two equation. What will I get? Mg sin phi upon mg cos phi is equal to Fs max upon R. So this gives me tan phi is equal to mu s max. From here, if I mark this as equation A and this as B, it is clear that angle of friction is equal to angle of repose. From A and B, angle of friction is equal to angle of repose. I hope there is no confusion in this concept now. So I'm just drawing a central line which is separating these two concepts. And this right side things are for the explanation only. So I'm just keeping it in the this is for explanation. So I hope the concept is clear now. That's all for now and have a nice day.